Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. In this video I will solve 5070 for 1 May June 2023 paper. Let's start. The student uses chromatography to separate the dyes in a food coloring. Figure 1.1 shows the apparatus the student uses. So this is the apparatus of this experiment. This is chromatogram. This is chromatography paper, or you can say chromatogram, and chromatogram paper placed in lid after preparation. So just draw the start line on which mixture is placed uh, and dip into the beaker containing solvent. So there are two solvent in chromatography experiment used commonly, that is ethanol and other is water. But substance which you are going to identify should be soluble in these solvent. Name apparatus X, that is X, apparatus X is a beaker. State why it is important to have a lid on X. Prevent evaporation of solvent. State why the start line is above the level of the solvent, drawn in pencil. So dyes does not dissolve of paper into the solvent. So dyes does not dissolve in solvent into the solvent. Drawn in pencil as line does not, drawn with pencil as line does not smudge the solute travel up on the paper. So RF value of one of the dyes in the food coloring is 0.60. In the separation, this dye travels 5.7 cm. Calculate the distance traveled by the solvent during the separation. So RF, this is the formula to calculate the distance traveled by the dye, by the food color, and distance traveled by the solvent. So RF is, we have RF is 0.60 and distance traveled by the food color is 5.7 x. So x is equal to 9.5 cm. So this is 9.5 cm. So next question is question number 2. White vinegar is a colorless solution containing ethanoic acid. This is vinegar containing ethanoic acid. A student titrates 0.400 mole per dm cube aqueous sodium hydroxide with two samples of vinegar A and B. The student does 4 titrations, 2 with A and 2 with B. The student step 1 uses a volumetric pipette to add 25 centimeter cube of 0.400 mole per dm cube sodium hydroxide to the conical flask. Please remember this, that sodium hydroxide is taken in conical flask. Add 5 drops of an indicator to the conical flask. Step 3, add A from burette while swirling the contents of the flask, adding drop by drop. Step 2, add 5 drops of an indicator to the conical flask. Sorry. Step 3, adds A from burette, 2 with A. The student does 4 titration, 2 with A and 2 with B. So we have taken 2 sample of vinegar A and B. So that's why please underline these uh, focus point which are using in the whole experiment. So A from a burette while swirling the contents of the flask, add in drop by drop near the end point until the solution just changes color. Step 4, empties the conical flask and rinses it with distilled water. So keep it in mind that conical flask can be washed by using tap water and distilled water. Okay. Repeat steps 1 to 4 step and repeats 1 to 4 while using another experiment. Repeat step 1 to 5 using B instead of A. So are using 2 samples A and B. Now first do experiments with A, all these steps with A, and then afterwards with B. 2.1 shows the burette readings for the 2 titrations with vinegar A. This is initial reading and this is final. This is initial of titration 2 and this is final. Reading 2.1, final burette reading is 24.9. So this is the 24.9 and first reading, initial reading is 0.0 and the second titration is, this is 37, 1, 2, 1, 2, 3 and 4 and second reading, second titration 37.4 and 12.3, 1, 2 and 3. So these are 2 titrations, initial burette. Now volume of A used by subtracting final burette reading to 0.0 of initial burette reading. So we get 24.9 and in this 25.1. So we have 2 volumes. Figure 2.2 shows the burette. This is the result readings for one of the titrations with vinegar B. So this is second sample, the reading with second sample. Final burette reading 12.6 and initial burette reading is 0.1. So this is 12.5, this is final burette reading 12.6. 1, look at this. So this point normally used, lower meniscus 12.6 and 0.1 and the volume of B used is 12.5 in titration 3 and this is 25.3. Look at this. This is lower meniscus. For colorless liquid, lower meniscus is used and for colored substances like potassium manganate, If used in burette, then upper meniscus. So this is 25.3, and 12.6 is the initial reading. This is 12.6. Now we have 12.5 and 12.7. Calculate the mean volume of A and B needed to neutralize 25 centimeter cube of 0.400 mole per dm cube. So how to calculate the mean volume of the burette? 24 by adding 2 burette reading 24.9 plus 25.1 divided by 2. So in this way we get 25 for the mean mean volume of A, and the mean volume of B is 12.6, like 12.5 plus 12.7 divided by 2. So this is mean volume of B, 12.6. Suggest why the titrations using A and B are repeated to check that the results are reproducible. Our results are accurate, you can write down. The equations for the reaction between ethanoic acid and sodium hydroxide is shown. Keep it in mind so that sodium hydroxide is taken in flask. Look at here, sodium hydroxide to a conical flask. Use a volumetric pipette to add 25 centimeter cube of 0.400 mole per dm cube of sodium hydroxide to a conical flask. So to answer the answer to B shows the mean volume of B used to neutralize 25 centimeter cube of 0.400 mole per dm cube aqueous sodium hydroxide. Calculate the concentration of ethanoic acid in B. So sodium moles of sodium hydroxide is 0.400. This is the concentration into volume. This is the formula of calculating mole: concentration volume, concentration into volume over 1000. So 0.400 is the concentration of sodium hydroxide. 25 centimeter cube of this sodium hydroxide is used, divided by 1000, because this is in centimeter cube and this is in mole per dm cube, so that's why we have to divide with 1000. So the moles are 0.01 mole. So concentration in mole per dm cube, concentration always in mole per dm cubes. The concentration is equal to mole over volume. So mole is 0.01 and 12.6 volume, mean volume of the 12 volume of the ethanoic acid in B. This is in B. Look at here, 12.6 mean volume of B. 12.6 into 1000. So the concentration is 0.794, which is approximately equal to 0.8. Use your answer to D to calculate the mass of ethanoic acid in 500 centimeter cube of B. So this is the concentration here, D. Using this answer to calculate the mass of ethanoic acid in 500 centimeter cube of B. So this is 0.794. So first find out mole in 1000 dm cube into this volume 500 divided by 1000. This is cm cube and now this is 1000. So this is 0.397 mole. Mass is This is mR and this is mole. So the answer is 23.82. The mass is 23.82. Now moles of sodium hydroxide. We know that 1000 centimeter cube containing 0.400 mole. This is mole per dm cube. We know that this mole in 1000 dm cube. So what would be the mole in 25? So this is 0.01. By using mole ratio, sodium hydroxide and ethanoic acid 0.01. 1 is to 1 ratio. Look at here, 1 is to 1 ratio. And what would be the mole in 0.01 in ethanoic acid? This is ethanoic acid and this is sodium hydroxide. Now 25 centimeter cube of sodium hydroxide containing 0.01 mole of sodium hydroxide, mole ratio volume, this is volume, and now this is mole. So volume of 25 centimeter cube containing 0.0100 mole of ethanoic acid. So what would be the mole in 1000 centimeter cube? So this is x, so the answer is 0.4. This is in 25 centimeter cube. Okay, this mole is in 25 centimeter cube. Now calculate in 500 centimeter cube. 1000 centimeter cube, this is again volume and mole. 1000 centimeter cube containing 0.4 while 500 centimeter cube containing x. So the answer is 0.2 mole in 5 centimeter cube, 500 centimeter cube. So this is the mR of ethanoic acid. So mR of ethanoic acid is 60 and mole of ethanoic acid is 0.2. So by calculating mole into mR, we get 12 gram mass of ethanoic acid in 500 centimeter cube of A is present. Suggest why the conical flask is rinsed with distilled water and not 0.400 mole per dm cube aqueous sodium hydroxide between titrations. Distilled water is used to remove impurities, and if we use sodium hydroxide solution for washing the conical flask, so more volume of ethanoic acid is used to neutralize this volume. So that's why this conical flask should be washed with distilled water, not with the solution which is used. Some vinegars are brown rather than colorless. Suggest why this titration method would not be suitable for finding the concentration of ethanoic acid in brown vinegar. The color change could not be clearly observed because vinegar is already brown in color. So this is question number. This is all about of the titration question. Hopefully you understand. A student investigates, question number 3, student investigates solution W and copper 2 carbonate. The test, part A, the test that student does on W are shown in the, so please keep it in mind that this is W is copper 2 carbonate. And the further tests are shown in the table 3.1. Some of the observations for these tests are also shown. Add aqueous sodium hydroxide to W, solution remains colorless. Add dilute nitric acid, then add barium nitrate. So white precipitate is formed. So if by adding barium nitrate, white precipitate, this is test of sulfate ion. Add dilute hydrochloric acid, then add aqueous silver nitrate, white precipitate. Again white precipitate with silver nitrate. Flame test on W, no color is observed. This is test of chloride ion or any halide ion. White precipitate, this is for chloride ion definitely. And this is this test for sulfate. You can check from the table given at the end of the paper. So just confirm. Look at this. for nitrate. Add aqueous sodium hydroxide, for sulfate test. Add acidified with dilute nitric acid. This is test written over here. And then add aqueous barium nitrate. White precipitates are formed. And this is test written for chloride acidified with nitric acid. Then add aqueous silver nitrate. The same tests are written over here with the results. You can confirm with the test given at the end of the paper. Flame test on W, no color is observed. It means the solution no color is observed. So now look at the question. The student correctly concludes that ammonia is formed. If ammonia is formed, describe what else the student must have done to reach this conclusion. So add aqueous sodium hydroxide W, then warm the mixture. This is missing. And observation should be contained which ammonia gas is evolved, which turns ammonia gas is evolved, because in test 1 definitely ammonia is present. Ammonia gas is evolved which turns damp red litmus paper blue. State why the student cannot identify the anion in W from the observation in test 3. Because white precipitate of chloride as well as white precipitate of sulfate. So student cannot identify the test 3 because already sulfate ions, the test of sulfate ion is confirmed in the test 2. So that's why state why the student cannot identify the anion in W from the observation 2, because HCl contains chloride ion, so that's why we cannot, because already sulfate sulfate ions are confirmed. State how the test and observations show that W does not contain sodium ion. As there is no color is observed, it means sodium ion is would not give the color. Identify the cations and anions in W. So cations definitely will be the ammonium ion. So this is the ammonium ion test, which is incomplete. So and the second anion, the cation is sulfate. The student add dilute hydrochloric acid to copper 2 carbonate, a gas and a solution are produced. State the observation that contains the production of a gas. Lime water turns milky when gas passing through the lime water. So this is how to confirm the carbonate ions or confirm the gas, because if carbonate is there, definitely carbon dioxide is produced. If metal is there, then hydrogen. But in case of copper 2, any carbonate ion or any carbonate, for any carbonate compounds while reacting with dilute hydrochloric acid, always carbon dioxide is produced. Describe how to do a flame test to confirm presence of copper 2 ions in the solution. Take solution of copper 2 ions and place it on the blue flame of the Bunsen burner. Flame changes color to blue green. So this is how to check the copper 2 ions in the solution. Describe one other method to student could use to confirm that the solution contains copper 2 ion. You can use with ammonia solution or with sodium hydroxide. So test is add sodium hydroxide in test tube containing copper 2 ions till the change seen, and then excess. Blue precipitate formed which remains insoluble with excess of sodium hydroxide. This test confirmed that solution contains copper 2 ions. Baking powder is used to make cake rise. When water is added to baking powder, carbon dioxide gas is released. The longer the baking powder is stored, this is very important. So please read the question very carefully. The less carbon dioxide it releases when water is added. So plan an investigation to show which of two different samples of baking powder has been stored for longer. Your plan should include the use of common laboratory apparatus, the 2 samples of baking powder and water. No other chemicals should be used. So you know that this is very important to know that you should know that there are 6 marks for the question, and always the marks, these are the plan should include. Apparatus should need it carrying 1 mark. The method used, description of the explanation of the method is 2 marks, and measurement to take 1 mark, and variable to control 1 mark, and how to use the results, this is carrying 1 mark. So in this way you can get 6 marks when you fulfill these requirement. So you may draw a diagram. So there is option, you can draw or not. You may draw or may not. So may draw diagram to help you answer to the question. Apparatus balance conical flask, measuring cylinder or gas range to measure the volume of gas. Method, measure the same mass of 2 different samples. This is control variable. You know that these 3 same, this is one same mass of control variables. This should be constant. Same mass of 2 different samples with same surface and with same temperature. You placed in the stored in the these 2 samples. So measure the same mass of 2 different samples A and B with same surface area of baking powder and with same temperature. Add excess amount of water in both conical flask attached with the gas range and stored it for different interval of time, like conical flask A with less time and conical flask B for with more time. Measure the volume of the gas, or can measure the, you can write down measure the volume of gas, or can measure the mass of the 2 conical flasks stored for different times. Conical flask A, which is stored for less time, produce, this is you can say result. So after measuring the gas, conical flask A, which is stored for less time, produced more gas and turned lime water taken less time. Lime water milkier. Gas turns lime water milkier taken less time, and conical flask B, which is stored for more time, produced less gas and taken more time to turn lime water milky. So this is all about of this paper. Hopefully you understand this paper, and keeping these points in your mind while solving the paper 2024, upcoming paper 2024. Okay, if you understand, then press the like button and comment it if you like the video, and any question which you can ask regarding this video. Okay, thank you. Allah Hafiz.